Hello, everyone. Thank you for joining this session. Hi, Naso.
Hello.
We just
Okay.
started, so you can start with the introduction.
Again, welcome everyone. Sebastian, happy to welcome you and to have this presentation from Metafacts. Peter Hasse and Sebastian were perfected this technology for almost 10 years. So actually, the same basic framework that's behind the Metaphactory was also part of the now famous project of BBC for the Soccer World Cup in 2010. And the results are worthwhile. Metaphactory is the one of the very few middleware frameworks and tools at all that can deal with big knowledge graphs with billions of statements and like Wikidata. So scalability is not the only thing. They are paying a lot of attention to what people really need to take care of different tasks, usability, collaboration. But that's what Sebastian will be talking about. Sebastian, the floor is yours.
Thanks a lot, Naso. Yes, so looking forward to talk about collaborative graph management and exploration with Metaphactory today. So just to set the stage, I think I don't have to go very deep into why knowledge graphs are amazing. I expect you have listened to the sessions already today and yesterday, and I can build on top of that. But then so are also pandas. They are amazing as well. Why am I saying that? Pandas are really cute while they are small. Similarly, knowledge graphs, but then it gets more complex quickly. So be aware of where this is going. And we have seen a lot of projects that started out with a very cute knowledge graph. And I have one example here based on a Wikidata exploration system we are hosting together with Ontotext. And we can easily understand this knowledge graph. You can give that to a user, they can look at it, they can understand what's happening here. We see that pandas are not only cute, they are in that same taxon family up to bears, and we see the carnivora on top. So we can use knowledge graphs to highlight interesting information. But then the reality is, as we add more information when talking about semantic models, controlled vocabularies, bring that together with the meta and instance data, this becomes much more complex, and it's no longer this easy thing to easily work with. And there's a good number of expert tools out there that help you work with the knowledge graph, and this is something we have also focused on for quite some time now, as Naso already pointed out. But we are seeing that knowledge graphs are now in a maturity state where there is a new challenge. And it is to scale the idea of a knowledge graph in the enterprise. And I don't mean performance scaling or anything like that. What I mean is being able to capture the needs of everyone in the enterprise and finding a way to bring them into the knowledge graph. Create collaboration and contribution throughout the enterprise around your knowledge graph. So let's meet Jonathan. He's going to be our example going through this presentation. So he's often classified in different ways. He can be our business sponsor. He can be the target user for interacting with what we are building with the knowledge graph. This could be our key expert contributing a lot of domain knowledge to the knowledge graph. And it very often is a person not in IT and not with an IT background. So the big challenge for Jonathan is, how do I contribute to and benefit from a knowledge graph? And that's something we have seen in so many projects over the last years, that knowledge graphs are very often driven from a very technical view on them, which is very right and important. But there comes this point where the business has to be part of it, where domain experts have to be able to contribute all of their knowledge into the knowledge graph. And where business users have to be enabled to utilize all the information that is accumulated in the knowledge graph. So what are the different things we have to take care of? One important and first step is building a semantic model. And not just building a semantic model, but building it collaboratively, bringing in domain experts throughout the enterprise and providing them a way to understand what such semantic model is about, providing them a way to contribute to it, and work together with ontology experts and others in the enterprise. Because, as you're probably aware, ontology expert is a key role here, but I have not talked to any company so far, not seen any enterprise where there was more than a handful of such experts available. So what is the most common practice we see for involving domain experts in semantic modeling? It's whiteboards. It's bringing them together to draw together on a whiteboard, define, well, what is our model? What are we actually talking about? What's our domain? What do we want to build a knowledge graph on? Screenshots taken of that, stored in collaborative systems like Confluence, creating discussions and comments in there. And then at the end, there is a poor ontology engineer having to translate that manually into RDF. And there's a lots of back and forth. So this is a continuously evolving thing. Such a semantic model, the domain model is not a one shot and you get it right. So this is a challenging process with so many breaks between different systems and approaches. So obviously this is not something that Jonathan is going to be happy with, because whatever feedback he provides on that whiteboard in those discussions, it's not going to reflect exactly like that in the RDF. It's going to be really hard to translate and understand how one affects the other and how those ideas are in the end then translated into the knowledge graph. We have seen a number of more advanced models using mind mapping tools, so already having that in a kind of a digital format. Again, manually translating to RDF most of the time. Using that mind mapping tool also to capture comments, to capture ideas. Or on the other side, using the all-present Microsoft Excel, using spreadsheets to capture more in a tabular form, what are relevant properties, relevant classes, and so on. And then having come kind of a semi-automatic translation to RDF. But again, you must be kidding that can't be the tooling here. We are going to a knowledge graph, and now we are talking about the Microsoft Excel and tabular formats again. And also mind mapping tools. Well, yes, it has the visual representation we want, but it does not have that understanding of RDF, and we can have a manual translation. So what we envisioned a few years back is having something that works in the same way, works like a whiteboard, works like a mind mapping tool, and allows you to just put your concepts, classes onto that, connect them. So really just saying, well, I have an additional class, giving that one a label, connecting it via relations, reusing existing relations, reusing existing classes, importing ontologies and extending them, all of those things in a way that it directly creates RDF in the background. And that's what we have actually built in the Metaphactory tool. So what you see here is a screenshot from the actual tooling where you can right away do that, where you can collaboratively work on that, where people can create a new class, can create a new relation, document everything about it, all the way to defining cardinalities for which we are utilizing shackle constraints. So it brings together the best of OWL and shackle, directly translates everything into RDF, directly stores it in the underlying graph database, and it allows you to work in a way that also Jonathan will understand what's going on. So an easy way to bring in your domain users and domain experts and all of their feedback into this process. Collaborative knowledge management obviously is not a thing that happens usually only in one tool. So we are connecting with Git for versioning, providing you a more advanced versioning workflows that you can also use to then, for example, integrate other tooling like Protégé and others, where your knowledge graph engineers or ontology engineers can then also further work on those models, provide additional OWL axioms that might not be easy to represent in a visual way, or might not really be how your domain experts would be modeling. The second step is defining the user experience. So if we go back to this graph, well, how we store and manage knowledge, the way we modeled it, is not necessarily how users want to interact with it. They might only be interested in a subset of that. So they might only want to see which other taxa have been mentioned in research together with pandas. So they want to have a kind of inferred view on top of that, where they don't have to traverse every relation, every connection in the graph, but they see specifically focused on what they are interested in. And honestly, not everything is graph. A lot of the user experiences we see working well are not graph-based. They are tables, they are maps, they are charts, which are just better catering to certain information needs that we experience with the customers we are working with. So the way we are approaching that in Metaphactory is providing a way to specify what kind of information you want to use in a visualization and putting that kind of as an overlay over your actual knowledge graph. We are utilizing a low-code approach to that, so you can really just drag different components, parameterize them with a Sparkle query, and through that even empower power users to consume knowledge on their own, to build such interaction patterns to their needs. Or you can provide that as a service, very much following that idea of the composable enterprise, where you have packaged models, domain models, together with packaged UI templates that define the complete use case and that you can ship, combine to then bring user experiences to the different departments and end users interacting with the knowledge graph. Again, this is obviously everything versioned in Git, so that you have a simplified and integrated experience in building that and advancing that also together with your semantic models or ontologies. So if we put it all together, that is the idea behind what we're doing with Metaphactory and what we are successfully doing with our customers in all kinds of verticals. So it's starting out from just improving data literacy across the enterprise. So providing an out-of-the-box intuitive interface for searching, browsing, exploring, and authoring your knowledge graph. Meaning you can just connect that to a GraphDB repository. You can right away explore what's in there. You can interact with it without having to do any customization, configuration, or anything like that in Metaphactory. And this kind of a linked data browser and exploration interface already creates awareness with your business users and domain experts, with your data scientists on what's actually in there. How can I use that? What's the benefit of that? Then the visual knowledge graph modeling, which is not only the ontology modeling, but also taxonomy management, dataset management, allowing them to have simple interfaces to contribute to that, to review what is being built there, to get their buy-in on those domain models, and a common understanding of where this knowledge graph can be taken next. And then all of this based on this low-code platform approach, meaning you cannot only modify how that user interaction works, and you cannot only infer over those triples in how you want to visualize them to your business users and end users. But you can also use that same concept for adjusting or augmenting the knowledge graph modeling experience. You might want to have a more restrictive workflow for your users where they can't just put in a new class, but they have to specifically select where they want to place that in the existing hierarchy of classes, where they get guided through selecting the right property. So rather than creating a new one, understanding if there is one that could be reused. And all of that is different in every company we have worked with so far. So there's no one size fits all, which is why there is a default in the platform that you can start with, and then you can adjust that to your specific needs. So what is the full process end to end? So it starts with really understanding the information need together with the business users. And we very often use this default linked data exploration if there is already a knowledge graph to browse through the data, look for relevant data points and understand how it would be better represented. If we are starting out from scratch, this is very often just a creation of some user stories. And then there's this collaborative effort of modeling the domain model, of getting an understanding of where does data come from and how does it correctly map into each other, and what's the meaning of that data. Then obviously connecting the data into it, validating the data, for which we can again utilize the shackle constraints and definitions, building the user experience in that platform, and then getting that validated by domain users, business users, getting their feedback and quickly iterating over that. So the way we usually do that is in a 2 to 4 week interval with 1 to 2 week sprints to drive this forward. So really a fast path to getting that value out of a knowledge graph. So obviously, there's one big question around that, and that is how can I get started on that? So what is the best way to get started with working such a system to better understand how this works? And we have created a number of demo systems that you can easily interact with, and I will also jump into one or two of those in a second. And then there is also our get started experience where you can just get your own Metaphactory instance to set this up. But let's maybe first look into the actual experience of walking through that. So this is, for example, a demo system that we have set up on Wikidata. This is running on top of GraphDB, and you can just use that to explore the Wikidata dataset. So we have simple search interfaces where we can search for panda, and we see there's not only the species of mammal, there's also a Mexican band called Panda. Panda is a family name. There's the Panda 3D game engine. But we are interested in the animal here. We can from here explore connections. So we can see, for example, what we had on the parent taxon. So we can see panda, the great panda here itself is the parent taxon of a number of different types of pandas. We can further explore from here. We can see the taxon rank for those. So we see those are all subspecies. We can quickly check what the taxon rank for this one here is. So we see this is a species. We can get additional information in the form of a knowledge panel. And when we find something we consider interesting, so their main food source, for example, we can drag that into a clipboard. I have to log in for that. Just a second. So if we find something we consider interesting, we can drag that into a clipboard, store information about that, organize that also in different sets in our clipboard if we want to, and then easily jump into that and explore information further from there. So we can always use this again kind of as bookmarks also to jump back to relevant resources and explore them. And this is all stuff that comes out of the box that you just deploy on top of your knowledge graph to get familiar with it, just in the same way as the ontology and vocabulary management that I talked about earlier. So what I wanted to quickly show now is how we can utilize this low-code exploration experience to build a specific view on our data. So as you saw here, we could really explore all of the details of pandas. We can, for example, see that it's the main subject of a number of research articles. We can see for those the related authors. But then again, this is probably not how you want to explore this information and how you want to display it. So it's very likely you want to have a simplified view on that. So what we're going to do is we're going to create such a table as we saw earlier. So I'm going to put that in here. And what we have is a very simple syntax. So we have a little bit of HTML markup saying that we want to have a 20 pixel margin around our table. And then we put a table in here, which is based on a Sparkle query, where we select the relevant information. We also count articles. We say we want to have grouping enabled in that. And we additionally specify that for the articles, we want to have a sum aggregation over that. So that's the count of articles. And if we now look at that, just a second, most likely copied over something that it's the demo effect. Let me see if I quickly find the issue. Sorry, not sure what exactly went wrong there. But so this is basically the same table that we saw in the slide before that would be created out of that. And then we could modify that query to select other information and have an easy way for more of the power user to aggregate this information in the way they need it, or we can have predefined interfaces for our business users that abstract from the underlying graph. So just a few of the example use cases we have built in the last years. There's a lot of things in life sciences and pharma, from target discovery to clinical trial scoping, drug development and drug repurposing, clinical analytics dashboards to engineering for digital twin or spare part management use cases. So a lot of different places where you can apply this approach and technology. And with that, I want to thank you for the attention. And this is the link where you can reach out to us or get your own Metaphactory trial to connect it to a possibly already existing knowledge graph and just play around with it.
Thank you, Sebastian. The demo with Wikidata was spectacular. Only those people that haven't tried to do something with the big graph think it's just like that. You require very well designed middleware and well tuned front end tools to make this easygoing experience on a big graph. But yeah, luckily you have it. There were quite a number of questions on this. So is the Wikidata connector available out of the box? So if you get Metaphactory, what it takes to get the same working?
Mm-hmm. So there are a number of pieces that come out of the box with the platform that help you if you want to utilize Wikidata. So first of all, yes, you can just connect to a Sparkle endpoint that has the data set. We additionally have an integration that utilizes the Wikidata query service. So you can also utilize that for keyword lookups like we saw in that search interface. In the same way, we provide that also for GraphDB and other graph databases. And we have integrated federation capabilities. So very often you're not going to work with just Wikidata, but let's say you maybe want to query the public Wikidata endpoint and combine it with what you have in your GraphDB repository. You can easily do all of that within Metaphactory and then write queries against those federated sources and utilize that for your visualizations, or explore also across those sources in the platform as we saw it.
Okay, and I think you answered this question. The question was, is there other connectors other than Wikidata available? And the way in which this entire stack of technology works is that for each and every data set for which you can get the Sparkle endpoint, you can very easily get Metafactory working with it, right?
And not only Sparkle endpoints. So we can transparently federate over Sparkle endpoints. So you wouldn't even have to know which information will be found in which of the endpoints. But we can also federate over any kind of endpoint with default connectors also for SQL or for REST APIs. So you can write a federated Sparkle query against those as well.
Okay. Now there is a question that's related obviously to collaborative graph management. Is there connecting voting capability or workflow for approval? So imagine you have several people working on a project, and there should be a mechanism to allow them, approve changes and stuff like that.
Yeah, absolutely. So commenting or approval are probably some of the most common needs there. And we can have that in the platform itself. So you can basically manage that within the knowledge graph. And we would maintain additional triples as annotations, as information about that. Or the alternative, and that's especially interesting if there is not just one tool in use in your whole modeling process, you can have that orchestrated via a versioning system like Git. So we can utilize that together with pull requests and so on, being able to tag individual versions directly from within the tool, and then have a collaborative workflow driven through your versioning system.
Thank you. There was a question whether Metafactory has taxonomy management capability included.
Mm-hmm. Yeah, so we also have that. The ontology management you saw is basically in that graph view, because we felt that is the most intuitive way how you want to manage a semantic model or an ontology. For the taxonomy management, that is more tree-based. So we can have just a quick glimpse into that. So that is also part of the default platform, and we can see that for this interface, this is more tree-based and allows you then to interact with the vocabulary in this way.
Okay, thank you. Thank you, Sebastian. And everyone, you can reach out to Sebastian and Kai and others from Metaphactory on their booth. Thank you.
Perfect,
Bye.
thanks.